Hello everyone, my name is Shahrukhbek Yahyaev and I welcome you to our new computer architecture tutorial. So in this tutorial we are going to analyze our homework 1. As you know, the midterm exam questions are going to be really similar to homework 1. So if you understand the questions in our homework 1, good, there is a more chance that you will kind of get high score in your midterm. We're going to provide, or let's say organize, offline computer architecture tutorial on Saturday this week, but unfortunately this is not going to be recorded, so that's why I am now recording the brief short version of the tutorial that we're going to plan on Saturday for those who possibly may not come or may not attend our lecture on Saturday. Okay, so we're going to analyze each question in homework, and through analysis of the question we're going to revise some theory too. So let's start with the question number 1. So in the question number 1, you're gonna just ask it to choose or say whether this given diagram of final state machine is valid or not. So I guess you know that this big circles, or these ones that represent, let's say, states. For example, let's imagine that this states, there is 3 states, let's say, and this I'm drawing an arrow. This is the input. Let's say the input is 1. That means that, what does it mean, this arrow? If you give input 1 to this state, the next state is going to be this state. Okay, I repeat, if you, for example, let's say if the input given to this state is 0, now that means that the next state is going to be this state. Okay, so, and very basic rule is that whatever input you give, the outcome or result should be unique. What does it mean? Now, for example, let's draw again. This is the input, and this is a state. This is state, and this is state. So I'm drawing this arrow, and I'm giving input 0. That means if you give input 0 to the state, next state is going to be this one. But if I add this one, then there is this action breaks our uniqueness rule. Now our machine doesn't know which state is executed if input 0 is given to this state, because here next state is 0, here it's 1. We don't know which state comes next if input 0 is given to this state. Okay, so this breaks the rule. So as I told you, now the inputs given to one state should have unique result, unique next state. Okay, so now let's consider, or let's analyze 3 given states. Let me delete this one. So see here, let's analyze each states one by one, and let's start, let's say, from this. Let me draw it. Let me zoom in. Let's start from this one. So you see, there is 1, and if input is 1, it says that it returns to itself. That means, okay, you see, if input is 1 given, so next state is again itself. It's kind of a loop, right? But you see, there is also this one, this arrow. If input is given 1, if input 1, the next state, now it says that the next state is 0. So this phenomenon just breaks our uniqueness rule. So that's why it's not valid. This entire diagram is not valid because this state doesn't have proper results or proper next state identification for the particular input, in this case for 1. See here, if input 1, it says that it calls itself. Here it says it calls next state called 0, but it's not possible. Okay, and although this state, this state and other states have valid let's say follows the uniqueness rule. For example, here, for example, let's analyze this one. For example, here, if it's 0, it's loop. Okay, if it's 1, the next state. So everything is perfect. But again, this state breaks the uniqueness rule, so that's why we say this is not well formed. Okay, so let's analyze this one. So let's start from this one. So if 1, okay, good, 0, good. There's no double input 1, okay? So everything's perfect. And let's analyze this one. 0 state. If input 0, it calls itself loop, okay? If input is 1, so it's 1. So good, pretty good. And let's analyze this one. Okay, 0, if state is 0, if 0 is given, it's a loop. If it's 1, it calls the next state, so no duplication, so everything is perfect. This one is well formed. Okay, so let's analyze this one. Okay, as you see here, also something strange, but here please be careful. Here I'm going to introduce a new rule. There is also second rule of validity of final state machine says that each state should have the result given for a particular input. For 0 and 1. For example, if we consider that there is a state 0, for example, we should know what state or what state comes if we give input 1 or if we give input 0. For example, if it only provides the next state for input 1 but doesn't provide the next state for input, for example, is provided. If it doesn't provide the next state for input 0, then the diagram is not valid, because we don't know what happens if input 0 is given to a particular state. So that's why let's analyze the third one. And when I see third one, you see that first let's analyze this 0 state, right? There's a 0 state. As you can see, if input 1 is given, sorry, I confused. Yeah, if input 1 is given, the next state is this 0. It's good. For one, let's say for 1, the next state is given. And if input is 0, the next state is this 1. So good. For 0 input also, the next state is given. But now let's analyze this 1. You see that if input 1 is given, so next state is 0. Good. I'm drawing this one here. State 1. If input 1, next state is given. But what about if input 0? As you can see, let me firstly clean this everything in red, because we already studied it. So if 1, done. But what about 0? You can see it's coming here. So no next state given if input is 1. So that's why we don't know what happens or what state comes if we give input 0 to this state. So that's why this is not well formed. So again, I repeat, if you're given a task to identify whether the final state machine is valid or not, the first rule is to see whether it has only one result for the given input. One result, or let's say equals to one next state. One next state for an input, let's say. Okay. And second rule is that it says that each state must clarify. Okay, must clarify next state for both 0 and 1. Okay, for both 0 and 1, or for all inputs. Okay, for all inputs. So I hope it was pretty understandable for you. So now let's come to question number 2. Okay, so in question number 2, the objective is what? The objective is to fill out this truth table and fill out this final state machine diagram. So firstly, you have to understand that the information is given here also. The very first thing to understand is that there is a state, and this is a state. For example, 0, 0 is a state. Let's read, for example, this line. Yeah, here. If state, okay, let's read this one. If state is 0, 1, what? Here, if state is 0, 1, if input is 0, this is the input, okay? If input is 0, then next state is 1, 1, and output is 0. So what does it mean? Let's imagine that this is 0, 1, okay, and input is what? 0, and that means next state is 1, 1. And it also says that the output is 0, so output is written below the state, okay? For example, here, this is a state, current state, this is the next state, this is the input 0, and this is the output, okay? And vice versa, we can also analyze this current state. Let's imagine that 1 and 1 is a current state. Let me choose another color. And if input is 1, the next state is 0, 1, and the output is 1. Okay? I hope it was pretty understandable for you. This is a basic stuff, so you have to understand it before moving on solving this, let's say, problem. Okay, it's a problem. So let's start. There is not, to be honest, there is no algorithm to solve this kind of, or let's say to fill this kind of states and truth tables. The only way, as I see, to solve this kind of problem is just to firstly guess the conditions. For example, let's say we put here 0, 1, and then assume, or let's try to fill this truth table. Okay, firstly you assume that, for example, here 0, 1, and then you try to fill truth table, and whenever you see contradiction, for example, this line and this line doesn't meet or kind of show contradiction, then you assume that 0, 1 is not correct, and you, instead of 0, 1, for example, put 1, 1. Okay, and so now, like that, you try different combinations. Okay, let's say, yeah, combination. I think it's pretty good, or in more understandable way identifies what I'm going to explain you. So let's start from guessing, or let's try fill, for example, firstly this state, because we're given this given states. So let's say that this is 1, 0. Okay, this is 1, 0. Sorry, let's say it's a 1, 0, and yeah, let's say it's 1, 0, and see, we're given here current state. It's given that firstly I have to tell you that what is S1 and S0. This is S1. If this is state, this is S1, and this is S0. Okay, so it says that if here, if S1 is 0 and S0 is 0, and if input is 1, then next state is 1, 0, and something output. So I am saying that this is 1, 0. Sorry. So I'm saying that this is 1, 0, this state, and I'm assuming that this is input 1. So what I'm saying here, What does it mean? I mean, let's analyze this part. So I'm saying that if current state is 0, 0, and if input is 1, I'm saying that the next state is 1, 0, and here I have to write what? Output. Output, as I've told you, is below the current state. So below the current state here is 0. So here's 0. That means if current state is 0, 0, if current 0, 0, if input is 1, then next is 1, 0, and output is 0. This is not the I mean, I'm not just I don't know, let's say I don't know whether this solution is, or whether the state here is actually 1, 0. I'm just assuming, giving this truth table, okay? I'm just assuming, I'm trying to fill this truth table, and whenever I see, I mean, a contradiction, I will stop and I will then kind of conclude that the state here is not 1, 0, and I will try different combination, okay? But for now, let's start our guessing, assuming that here there is a 1, 0. So okay, so input is 0. So I feel here, so I feel here 0, okay? I think it's clear for you, right? I'm feeling here 1, 1, because you see, it's given. If current state is 0, 0, if input is 1, I'm assuming that input here is 1, then next state is 1, 0. That means I'm going to fill here 1, 0, I mean here, and output is 0, I mean this is given, I mean already here, okay? So let's continue. Whew. And next I'm going to conclude that, I mean, it's pretty logical. I mean, the first question I've already explained to you that one state only has one next state for a particular input. I mean, this state already has the next state for input 1, okay? So now here we have arrow, this arrow, this now here, let me delete this one. I'm going to change the color. Now here we have again the next input. So we know that for 1 we have already next state identified, I mean this one. So only 0 left. So that's why here I'm going to write 0. Okay. So here, as you see, if state is 0, 0 in input is 0, it says that the next state is 0. Next state is 0. And what about, sorry, it says the output is 0. Okay, because you know 0, 0, input 0 is given, so already we know that the next state is 0, I mean output is 0. And again here, as you can see, this is pointing to itself, so that's why next state is again itself 0, 0. Okay, I guess it's pretty understandable for you. And why I'm kind of for a moment hesitating is that I am solving it right now on Monday for the first time, and in order to kind of show you the natural way of solving, I haven't prepared solution beforehand. Okay, so we have finished it with this state. With this state. So now let's move on. So now we should kind of guess this input given to this 1, 0. For example, here, see that you can see. Let's analyze this one. It says that if current state is 1, 0, I mean this one, and if input is 0, okay, if input is 0, it says that the next state is 1, 1, 1, I mean 1, 1, and output is 1. So output is always below the current state. Okay, so that means if we take this as an example, or let's say as our next starting point of our guess, we should say that here, I mean, see, what I'm saying is that output is always below the current state. Current state is 1, 0, so output should be here. And I'm guessing that this input, this 0, is this input, okay? I'm guessing that this is input because, you know, there's no, I mean, arrow is given, I mean, there are not two arrows, I mean, for this current state, okay? So that's why I'm not drawing another, for example, arrow for another input. I'm not saying that we have here 0 input because we have only one, only one, no, sorry. I'm just assuming that now, as I see that we already have just one here, we only have input 1 for this 1, 0, 1, and next state in this case is 0, 0. But we have here that the next state is 1, 1. So that's why I am assuming that now here input is 1, 1, input is 0, and next state here is 1, 1. So I'm repeating. For 1, 0, we already have input 1 given, and next state is 0, 0. So but here I see that in this row I see that if input given for 1, 0, for this one, if 0 input given, next state is 1, 1. Okay, for this state input 1 is already specified. We only have one arrow, and this arrow must be 0, and I'm saying that as the next state is 1, 1, I'm just writing here 1, 1. Okay, so and also it's written that the next state in this case is 1. No, sorry, output is 1. So as you know, output is always below the current state. Our current state is 1, 0, so I'm writing 1 here. Okay, I hope it makes sense now. So let me delete this one. So yeah, and let me also kind of delete this one and write it a little bit clearly. So 1, 0, 1, 1, 1. Okay, and here we have input 0. Okay, let's continue. Let me also delete this ones. Oh, sorry. Let me fill here 0, 0. I guess this was 0. Yeah. And yeah, let's fill this row. I mean, it says that if stop. Not this one. Let's fill this row. This row. It says that if current state is 1, 0, that means if current state is this one, and if input is 1, I mean, we're considering in this case this arrow, this input, okay, then we have to say what's the next state. So it's by default given. This is going to be what? I mean, not by default, but I mean, it's already given. This is going to be this state, 0, 0. And what is the output? Where do we find output? It's always below the current state. Current state is 1, 0, and below 1, 0, this is 1. So that means output is 1. You don't get the output from the below of the next state, not from below of this 0, 0. You get it, I mean, the output is below, let's say under the current state, not the next state. I mean, it's not 0, it is 1. Okay, yeah, it's 1 here. So yeah, we are constantly let's say filling our truth table, everything. So let's continue. What we have now this state are done. I mean, we know what happens if input 1 given, 0 given. So let's now concentrate on this state. Okay, so Here, let me just delete it. Okay, good. So let's write a little bit beautifully. And now let's analyze this 1-1 state. Okay, this one. So here it says that if let's see this row. If input one is given to the 1-1 state, to this one, okay, to this one, then the next state it says that it is 0-0. So we already have 0-0 state, this one. So that means if we give input 1 to this state, to this 1-1, the next state is going to be 0-0. So that's why I'm pointing arrow to this state, and I'm writing here input 0. Okay, I hope you're getting everything. So what about output? Why output is 0? So output is 0. What does it mean? We don't have to just say why output is 0. We have to conclude. If output is 0, what does it mean? As you know, output is always below or under the current state. In this case, current state is 1-1. So that means we have to write this output value below the current state. And this is going to be here. I'm writing 0. I think now you see the way how to fill this finite state machine diagram, and have to kind of fill it using assumptions based on analyzing truth table. Okay, this truth table. So let's continue. We are at the end of our discussion. So let me delete this one, and let's say 1-1. So yeah. So now what we have now, as you can see, we know what happens. We know the next state for this state if input is 0. But what about input 1? What happens if input 1 is given to this state? Okay, what is the next state? Let's analyze now this one. It says that if current state is 1-1, if input is stop. Now I've made a mistake. Now I made mistake. Here it should be not 0 but 1. Okay, we analyze that this row, right? If input is 0 and 1, if current state 1-1, so next state is 0-0. Sorry, here 1. Okay, so now question. There is question. So we know what is the next state if input 1 given to this state. But what happens if input 0 is given? For this, let's analyze this row. So it says that if input 0 given to this state called 1-1, next state is going to be 0-1. So we only have one empty circle, so that's why I'm writing here 0-1. Okay, 0-1, and it says that, oh sorry, what happened now? So it says that if input is 0, next state is 0-1, and the output is 0. We know that output is 0 because, below the current state 1-1 there's already what? 0. Let me point it with different color. This one. Okay, so yeah, I think it's pretty understandable for you right now. So wait, I deleted. If 1, it's going to be what? 0-0-1. I guess, yeah, 0-0-1. It was, yeah, this one. So yeah, I'm writing here 0-1. We're analyzing this row. So yeah, and I'm pointing at this one, 0, right? If current state is 1-1, if input is 0, next state is going to be 0-1. According to this row in truth table. So shall we continue? Okay, so now yeah, now let's analyze. I mean, we're done with this state, this state, this state, and we only have to identify what is the next state if input 0 and 1 is given to this state, to the state called 0 1. Okay, so for this, let's analyze these two rows. First of all, let's start with this one. So it says that if stop. Firstly, let's start with this one, second one. It says that if input 0 if input 1 is given to the state 0 1, so the next state is going to be 1 0. So I'm drawing this one, right? I mean, if current state is 0 1, next state is 1 0, and input was what? 1, right? I'm just writing here 1. And output, what? Output, as you know, I'm repeating 100 times, output is always below, under the current state. Current state is what? Current state is 0 1, and below 0 1 there's 1. So thus, if input 1 is given to this state, output is 1. Okay, so now let's let me delete this one, and let me write here 1. Yeah, now let's concentrate on this row. So now we know that what happens, or what state is called, if input 1 is given to 0 1 state. But what about 0? What about input 0 is given? Yeah, what about input 0? Now let's analyze this one. Let me draw it clearly. Yeah. So here we have a row. It says that if input 0 is given to the state 0 1, something it's 3 empty cells, but you know, we have only one existing arrow. Okay, for example, let's assume that we didn't have this arrow. Then it was our task to kind of predict, yeah, which state will be called, or would be called, if 0 input is given to this state. For example, we would be able to say that then we would call this one 1 state, or 1 0 state, or 0 0 state. Okay, but our life is now easy because we already have one arrow. Now we have to just kind of write the value of the input. So only input 0 left, because we already identified that if input 1 is given, the next state is going to be 1 0. So I'm just writing here 0. Okay, if input is 0 of this state, let me choose another color. If input is 0 of this state, the next state is going to be again itself. So it's going to be what? 0 1. 0 1, and output is going to be 0. Stop. Stop. Output is going to be 1, because you know, below, we already have this 1 here, right? Output is going to be 1. Output is always below the current state. Current state and the next state are the same, and below this current state already we have 1. So we have successfully finished this discussion of the second question. Second question of the first question. It was part B. So I think that now you know how to fill the final state machine diagram or truth table. Firstly, you have to understand that you have to analyze the given truth table, and based on truth table you have to make assumptions, guess, and then based on your guess you have to try to fill in the truth table. And whenever you see the contradiction, you just stop and you try another combination or another guess. Okay, so I hope it was understandable for you. Now I'm going to finish this video, and it was pretty long. I'm going to analyze another parts in the next videos. Thank you for your attention.